Hey, thanks for watching. In this video, we're going to talk about a category of problems that can really be quite serious, and that is moisture issues on vents, on ducts, and on equipment. And so we see this as condensation. Often we'll call it sweating ducts or a sweating vent. And the reason it's serious is because when you have condensation buildup, not only is the moisture in that location a problem because you can get some growth there, but it also often represents a bigger humidity problem or a bigger moisture problem that can lead to a lot of respiratory concerns. If you take a look at this chart, it shows that within the conditioned space, we really want to keep our relative humidities between 40 and 55% if we can, if at all possible. If it creeps up into maybe the low 60s, that can be okay, but once we get any higher than that, that can be a challenge. Not only do we want to keep things from condensating because that causes issues with growth, but we also want to think about the conditioned space and make sure that we keep our humidity under control. So again, we're going to talk about three primary areas: sweating vents, sweating ducts, and then sweating equipment. And let's start with sweating vents because that's the one that has the most to do with what's going on in the space itself. And so the reason why a grill or a vent, diffuser, whatever you want to call it, is going to sweat is because the temperature of that grill or diffuser or vent is hitting the dew point of the air. So there's really three different categories of things that can cause this problem. The first and the easiest to fix is that you have humid air intrusion around the vent itself. So the first thing I suggest is remove the vent, look up inside, and see if you can seal inside of that boot or can or whatever you happen to call it in your part of the country. See if you can seal around that area to prevent moist air from making it in around that vent. And so that's a really easy and common thing. Sometimes you can use something like foam tape in there, or maybe a little silicone or a little bit of acrylic latex caulk, maybe even a little mastic on the top side of that boot. You can seal that to the drywall or to the floor, depending on if it's a floor or a ceiling vent. But a lot of times that will help solve that problem. If that is already taken care of and you don't have issues with moist air intrusion around it, well, now you have to think about the temperature of the vent and you have to think about the dew point of the air in the space. First thing to remember is that dew points can change as that air creates stratas within a space. So if you have a really, really high ceiling and that vent is sweating up at the ceiling level, you may have a different dew point air down at the bottom. And that's something that sometimes you can solve with things like destratification fans in order to help mix that air. So ventilation can help in some situations. But more than anything else, in order to prevent sweating vents, we really need to control the humidity in the space. And so if you're seeing relative humidities that are creeping up above 55%, then the first thing to do is to control the humidity in the space. Now, the tricky thing is that in many cases, running lower fan speeds, running lower blower speeds, running less CFM over that evaporator coil will result in colder air, which will result in a lower temperature vent, which we tend to think, well, that's going to cause more sweating. But also, when we run lower airflow over that evaporator coil, more moisture is removed from that air, therefore dropping the relative humidity in the space. It's something that we call sensible heat ratio, or SHR. When we run lower airflow over an evaporator coil, if the piece of equipment is functioning the same, meaning you're moving the same amount of refrigerant, then you're going to dehumidify the air more because you're going to have a colder coil, thereby changing your sensible heat ratio, meaning your sensible heat ratio is going to drop. Sensible heat is the change in temperature, and latent heat removal is the moisture extracted from the air. So in other words, we're going to remove more latent heat by the equipment when we run lower fan speeds. But in a lot of cases, technicians are going to go to a situation with a sweating vent, and they're going to try to increase the fan speed. And why are they going to do that? They're going to do that because they want to warm up the vent itself, and that will result in warming up the vent. When you run higher air speeds, you have higher air velocities. Higher air velocities means that you're going to have warmer air. And so by running warmer air, it stands to reason that you're going to have a warmer vent. But the problem is, in doing that, you solve it on one side of the equation by warming up the vent, but you cause more of a problem on the other end because you don't dehumidify as well. And in order for us to solve this problem, we have two ways of solving it: either reduce the humidity in the space while keeping the vent temperature essentially the same, or warming up the vent temperature while keeping the relative humidity in the space essentially the same. My approach is to really approach it by reducing that relative humidity in the space if the relative humidity is the problem, which generally speaking, that's what you're looking for. So it's things like having a space that has high relative humidity, maybe because overall the system is sized improperly, it's oversized, so it's short cycling and not dehumidifying. Or maybe you have a customer who's opening the doors into the space during humid times, and so a lot of air is getting in that way. Maybe they're cooking a lot in that area, and so there's a lot of moisture from there that's not being ventilated with a proper kitchen exhaust, or maybe it's being recirculated into the space. Or maybe they have something like a lot of can lights going into an unconditioned attic where that moist humid air is infiltrating into the space due to air leakiness. So you want to look at air air leakage. You want to look at, are they running ventilation properly? Are they opening doors? All those sorts of things. And a really great way to help solve this problem is first do a blower door test to see how leaky is the space. And there's a couple different techniques there. If you're not familiar with how to do a blower door, that's a whole different video, and we've done some of those videos as well. A couple of really great resources for learning more about that is looking at manufacturers of blower doors like Retrotech and the Energy Conservatory, and then also Nate Adams. My friend Nate Adams has done a lot of really great discussions on this. Also did a podcast with Joe Medosh in the past where he talks about blower doors. So you want to learn more about that. But what the blower door helps you learn is the space nice and tight? Because when you have very leaky spaces, you're going to tend to have more moisture. So that leakiness is a really big factor in moisture making it into the space. So when you're dealing with an issue of a sweating vent, it's much easier to address it by keeping the moisture from getting into the space in the first place through proper ventilation and proper air sealing than it is to try to get it out. But if you've got no choice, well, then you have to look at either resizing equipment, maybe adding dehumidification, and maybe adjusting your settings on your equipment, depending on the type of equipment that it is. But just know that if you reduce airflow going over that evaporator coil, you will dehumidify better, but you're still going to have a colder vent. And so now you're kind of in the same situation. So generally, just changing fan speed on AC equipment usually isn't going to solve the issue of a sweating vent. But again, it comes down to the dew point of the air and the temperature of that vent. If that vent hits that dew point temperature, then it's going to sweat. A couple different devices that I suggest using to measure dew point, because a lot of people don't even know how to do that. My favorite is the psychrometer that comes in the Fieldpiece Job Link kit. That's what we use most often. That's a great psychrometer. You can use the Fieldpiece app or the Measure Quick app in order to get relative humidity, wet bulb, and dew point. You can also use the Testo 605i. If you're using the Testo app, as shown in this screenshot here from the Testo app, it says TD, and a lot of people don't know what that is. That is temperature dew point. So that TD means dew point. So that's an easy way for you to do it. And then also UEI makes it as part of their Hub 6 kit, as part of their Hub kit. They also make some really nice psychrometers that you can use. But regardless, in order to see what dew point is in a space, you have to use a good quality psychrometer. You have to let it acclimate to the space humidity. And that's one of the really big starting points. Before you start diagnosing and figuring out exactly what to do, first see where your relative humidity is in the space. And then you can look at things like maybe your vent surface temperature. Now that can be tricky to measure. Sometimes you can use an infrared thermometer if you get right up against it to measure the surface temperature of that vent. But now you have to know a little bit about emissivity and all that, and you have to know how to properly use infrared or thermal imaging. And that's another skill that you can't just jump into it. You have to understand how that works, otherwise you'll get incorrect readings. But again, what we have to do is either control the temperature of the vent or control that relative humidity in the space, and generally controlling the relative humidity in the space is your best bet. Item number 2 is sweating ducts in an attic. And so sweating ducts in an attic is a completely different category of problem. Attic, crawl space, basement, especially if those spaces are unconditioned or they're conditioned differently than the rest of the house.
So here is the supply plenum, the original supply plenum for downstairs. This is all original ductwork here. And there's just moisture that's building up. This is R6 insulation. Currently in the attic, we are at a 77.7 degree dew point. So any surface that gets below 77.7 degrees will start to sweat. So you know that air in the ductwork is going to be 48 degrees or so, and the insulation, the R value on all this ductwork just isn't meeting it. So we kind of have two options: decrease dew point or increase insulation. This is our supply plenum, sweating a bit here, but it's not just there, it's just sweating everywhere. This one's going down into a cell down here. Even here, it's just, you can see it's just wet.
So there's no venting.
Okay, so this attic has icing along the top. They vented the top plates here, which those shouldn't be vented. And then this space in the attic needs to be controlled, climate controlled. So we need to dehumidify and control the temperature in this space. But multiple ridge vents they cut out, which is a really, really poor design, given the fact that we're isoning everywhere. Here we have a 5-ton unit for upstairs, a bypass damper based on static. One zone here goes and feeds the master suite, and closet, bathroom, etc. Our other zone comes off here and feeds the rest of the upstairs. Really high humidity upstairs. I'm gonna get in the attic here. You can see we're condensating a bit here. Our unit's condensating, sweating. Our secondary pans filling up. And this is just high humidity up here. All right, so here we have an air handler inside of the attic. Obviously ductwork inside of the attic as well. What we were experiencing was the unit would sweat so aggressively because the cabinet itself was hitting dew point that the secondary pan would actually fill up with water periodically. Also ductwork, the exterior of the ductwork due to the high dew point was also sweating pretty much everywhere. What we did is we have isonine throughout the attic, so this is now a sealed attic. We use the Ultra Air SD12 split dehumidifier in this particular application, and so it has a slight cooling factor to it, as well as incredible dehumidification ability. Currently our relative humidity is 40% and we are 71 degrees in the attic space. So this cabinet, this is the Infinity Series carrier. So it's running in low speed dehumidification. That's usually when you see the most issues as far as equipment sweating or ductwork sweating, and there's absolutely no moisture anywhere on ductwork, on the equipment, and this whole entire attic feels incredible. Again, we have isonine throughout the attic, sealing off all the vents, any porch areas, and then no insulation. So all the insulation that was on the drywall traditionally got removed. Working amazing.
So when you have situations like the video shown where you have ducts that are sweating in the attic, there's two factors. There's the temperature of the surface of the duct itself, and then there's the dew point in the attic. It's not the temperature in the attic, it's not the wet bulb temperature, it is the dew point in the attic. And one thing that you'll find often is that as an attic gets hotter, often the dew points get quite high, even if the relative humidity percentage is low. So for example, I'm using the, it's called the Psychrometer app. That's the way I know how to describe it, but I use this all the time in place of using a psychrometric chart. Just makes it nice and easy. If you plug in 130 degree attic temperature, which is something we see in Florida quite often, even if you have a 35% relative humidity in that attic, that is a dew point of 93.5 degrees Fahrenheit, which means that any surfaces in that attic that get to 93.5 or below are going to start condensating. And that's very easy for supply ductwork to achieve that. Now, there's a couple different techniques you can use to solve this issue. You can use higher R value supply ductwork, or maybe wrap it in something like double bubble, some sort of another insulation on top of that. Insulating properly is super important, and so if you have gaps in insulation, obviously those will condensate water as that surface hits dew point. A better way to deal with this is to drop the dew point in the attic, and you can do this through ventilation in some cases. It's worse if you have a sealed, moist environment, and this is especially made worse if things like dryer vents are leaking in the attic or venting into the attic, heaven forbid, or bath fans are venting or leaking into the attic, or kitchen exhaust. So that's something I always look at first when I go into an attic that has any condensation in it, especially on the ducts, is moisture being added to this attic in some way? And then I look at, is it vented or unvented? And if it's vented, but it's poorly vented, sometimes venting it better can help a little bit when it comes to keeping that dew point lower, because you better communicate with the outdoor air. Now, I do not suggest using power vented attics, and the reason why I don't is because when you power vent an attic, you create negative pressure in the attic, and often that will draw air from inside the house into the attic space and actually reduce the efficiency of the home. Now, this all comes down into knowing your blower door number, knowing how leaky or tight your home is, and so there's some other factors here, but you definitely want to make sure that your attic is, if it is a ventilated attic, it needs to be properly ventilated. Sometimes the only option to solve the problem, though, is to seal the attic, to make it into a non-ventilated attic, which is where you use foams like open cell or closed cell foams, often called isonine is a trade name for that, and so you seal the attic and then you dehumidify and condition the attic. That's where we recently used an SD12 from Ultra Air and a high performance install that we did, and we used that in order to dehumidify and cool the attic slightly in order to bring it into the conditioned space. And that dealt with that problem that you saw in that video from Jesse, where all the ducts were sweating. By sealing up that attic completely, doing it properly, and then conditioning it, now that whole problem went away and the relative humidity in the attic came down, and also the relative humidity in the space came down. Because if you have an attic that is leaky to the occupied space, but you seal it to the outside and then you condition it really well with dehumidification, if you're in that type of market that requires that, then that's also a great solution. It's a pricey solution, but it's a nice long-term solution that's going to do a really good job of taking care of the problem. So when you have sweating ducts, your only options are, can you in some way increase the surface temperature of the duct, which you could also do by increasing airflow, but that is a dangerous equation, because when you increase airflow, especially when you already have a humidity problem, now you reduce the ability of the air conditioning equipment to dehumidify. And no matter what you do, your air conditioner is probably going to be the best dehumidifier in your home as far as the amount of moisture that it can remove. Really good dehumidifiers are still often not going to remove as much moisture as the air conditioner. They're just going to do it all the time. And so properly sized air conditioning equipment helps solve a lot of these problems. But again, when you reduce airflow, that's going to create colder air inside the duct. You're going to have lower velocity through the duct, which is going to create cooler surface temperature on the duct. So if you have a situation where the system does have low airflow, this is the other side of this equation. If your system has low airflow because the duct system is installed improperly, or it has a dirty evaporator coil or a dirty blower wheel or something like that, then that can sometimes be a fairly easy fix. You fix that airflow problem, increase the airflow, and then the surface temperature of the duct will warm up and it may stop sweating. But that's where looking at the surface temperature of the duct as you can and looking at that attic dew point, that's where I would always start whenever you have anything sweating in an attic or in a crawl space or in a basement. I often talk about attics because in Florida that's what we've got. That's the place you start, is look at that dew point, compare that to the temperature of the air in the duct, and see what's going to be easier. Is it going to be easier to drop the dew point of the air in that attic or crawl space or basement, or is it going to be easier to somehow warm up the surface of those ducts? Quick pro tip here, you're often going to see the worst problems with sweating ducts in attics that are pretty well sealed, pretty well insulated, and have some sort of radiant barrier. And the reason is because moisture tends to get trapped in those attics, so you have high overall moisture content in grains, high relative humidities, and low attic temperatures. When you have that low attic temperature, now you don't have as much heat that's conducting into the duct itself, and so that surface temperature gets cooler. So now you have that kind of prime condition for sweating on the surface of the duct. Often really hot attics that are well ventilated, you won't have sweating ducts just because that heat conducts into that outer jacket of the duct itself, keeping it a little bit warmer, driving it up above dew point. And so this is why, for those of you who have worked in hot, humid environments like Florida for years, and most of your duct systems don't sweat. Older equipment, most of your duct systems aren't sweating all the time. You may have some areas where the insulation is compressed that they might sweat a little bit, but generally they're not sweating. That's because you have this very hot, very well ventilated attic that now is actually heating up that surface jacket of the duct itself, keeping it above dew point. It's often when we try to make things more energy efficient, when we're running lower fan speeds in order to dehumidify better in the space, you can have these cases where the space itself inside the building is 50% relative humidity, but all the ducts in the attic are sweating like crazy. And that's why when you have high performance homes, I pretty much always suggest sealing up the attic, bringing the ductwork into the conditioned space by dehumidifying that attic, and now that kind of solves that problem. The final one that we see a lot in Florida is we see sweating equipment. Now in Florida, we generally have fan coils. We don't have a lot of furnaces, but same thing is true in furnaces. A lot of times they'll take this equipment and they'll put it into a closet in an unconditioned space, like for example, a closet in a garage, or even a closet in an area that may be conditioned, but it's not maybe kept as well conditioned, maybe a laundry room or something like that. Often these rooms will have gaps and cracks into the attic or maybe into the crawl space if that's where you are. And those gaps and cracks act as a gap for moisture to come up through those spaces. So whenever you're putting an air handler in a closet or something like that, you need to make sure it's well sealed. Now, obviously, if you're installing a furnace, an 80% furnace, that has to communicate with the outside. And so now kind of all bets are off. How are you going to solve that problem? And so now you need to just make sure that it's as well ventilated as you can. This is why in Florida, though we do see units sweat in garages sometimes, we see the worst sweating, the worst condensation in enclosed spaces. Because what occurs is that moisture is allowed to get into these enclosed spaces, it gets trapped, and then that air handler or coil radiantly cools that entire room. Often that will create cold walls that will then also condensate and build up growth. This is where sometimes you'll remove an air handler and you'll notice that there's all this growth right behind the air handler where it was next to the wall, and that's because that air handler is radiantly cooling that wall, dropping it below dew point and causing that moisture and that growth. What I often suggest, if you're going to have them in enclosed spaces like this, seal it off, insulate it, and condition it. That's a better way. Add a little return, add a little supply. Better yet, use dehumidification. I'm a big fan of supplementary dehumidification because then you can do it year round, but in some way dehumidify and control the dew point in that space. Just remember that when we ventilate, we're stuck with whatever the outdoor dew points are. And in Florida, we often have outdoor dew points that can reach 80 degrees. That's a very high dew point. That means anything under 80 is going to condensate. And so you really want to think about what your solution is going to be. Is it ventilating? Better, so creating more ventilation, more air to the outside, which could potentially have high dew points, or is it better to seal, insulate, and condition? And often sealing, insulating, and conditioning is the better thing. But first, always start with that sealing part. That air sealing is often the solution. Just like we mentioned with the sweating vents, when you have that moisture that's traveling in around the vent or around the boot, that can cause that vent to sweat, which is a big problem. By controlling dew point inside the conditioned space and the relative humidity, generally to that sort of in cooling mode, 75 degrees at 50% relative humidity, which equals 55 dew point. That's sort of the ideal condition for most people. Sometimes they want it a little cooler than that so that dew point may drop a little bit, but that 55 degree dew point is kind of a sweet spot. When you get into attics, that's often unrealistic. If you condition them with dehumidification such as the SD12, you can often get to that level. You may not always be able to, but you still want to keep those dew points as low as you can get them anywhere that you're going to have cold surfaces like ducts, vents, anything like that to prevent that condensation. For some of you who are in arid environments, we call these areas, that have desert, they have sand outside rather than green grass. None of this applies to you. You don't have to worry about hardly any of this because you just don't have those sorts of conditions. You have very low dew points year round. But when you're in other markets, even places like Ohio, you have seasons where you get high dew points, and that's where you have to think about and control these factors. Again, surface temperature we can control in some cases, but often the best bet is to control the dew point of the air. Hopefully that was helpful. Thanks for watching. We'll catch you on the next one.